today we are continuing on from last lesson.
Before we start today's lesson, we're going to talk about what aerodynamics is. If we have an object that's traveling through the air, all of the little particles are going to travel towards it and hit the object. Now, when that happens, it can't keep going straight, so they're going to start deflecting around the object like this. But when they get to here, there's this big vacuum because there's no air here. So they get pulled down into here. And they get pulled further in, and then they're going to start colliding with each other. And some of them are going to flow that way, some of them are going to flow that way, some of them are going to flow that way. And so we get this big turbulence behind it. So the idea of the simulation is to be able to determine how much turbulence you're going to get. But there are ways of reducing the turbulence. If you have an object that looks like this, then the air can flow down here and flow down here, and it'll all come off in like a straight line because there's no vacuum at this point that's sucking the air in, making a teardrop one of the most efficient shapes. And you'll also notice that it kind of looks like an aeroplane wing if we extend that off like that. And then you can have your big plane over here. So, these simulations are used by engineers to make their objects more efficient, but they don't have to be just for air. You could also do it with pipes, with water flowing through it, and you can see how the water flows through the pipe, making the pipes more efficient. And one of the best examples of this is called a Tesla valve. A Tesla valve has lots of little routes that look like this for the water or liquid to flow through. And the liquid flows through this, and it creates all of these vertices going in one direction and very little vertices going in the other direction. So it means that you've got a one-way pipe that only has no moving parts. Alright, let's get on to this.
Hopefully you've all finished your CAD for your CO2 race car, and today we're going to be testing it in simulations like the Matrix, but not. So I need you to all go to this website, which is on the learning management system called SimScale. It's up in the corner.
Hello, today we're going to be learning how to make an aerodynamic simulation like this. This will be able to help us understand how efficient our race car is going to be. To do this, we're going to go to this website here, SimScale. And we are going to create accounts. And then we're going to create a new project. So the title of this project has to be over 5 characters long for this website to work. So we can just type in F1CO2, and you can do the same thing for the description. And we don't need to add a category or a tag, and we just have to hit create project. Give it a little bit set to load. And this window pops up saying import geometry. So we want to hit import. Yeah, that doesn't work. We want to hit import from computer, and then find your file, and then hit import. And then we wait for this to load. So, once this loads, we can start creating a flow region for the air to flow through. This is kind of like a wind tunnel. So now that's coming, we want to go over here and click these 3 little lines and then hit add geometry option, and enclosure. That creates this box. Now we want to move the box from this front angle here, and we want to shrink it so that the edge of the box cuts this big box off the side. So we just get that shape. To do this, we want to move the x-axis to 0. We want to go a bit more. Let's go 10. Let's go 15, 18. That thing pretty close. We want to go a bit more. So 19, and that'll do. And then we can hit start. Let that generate. Give it a sec. So this is going to create a nice big box with a little cutout on the side for the CO2 race car. Now, we're only simulating half of the race car because the other half is identical and it doesn't really matter. And you'll be able to see all of the flow over just this one half, but it reduces the amount of time it takes to compute. And there we have it, it's created. So now we can hit create simulation and then incompressible because we don't want the shape to change, we just want the air to flow through it. And then create simulation. Next, we want to assign a material. The cars are going to be traveling through air, so we just click make sure air is selected and then hit apply. And then we need to choose where the air flows through, which is this box. And then we can hit OK, and that's done. And now we need to assign walls of the box. So we go boundary conditions. First one we want to do is a velocity inlet, this one here. And we're going to click the front of the box. And then we need to type in 10 in the direction of the box. Click OK. Now we want to add a pressure outlet to this face and hit OK. And lastly, we need to do all of the walls. So we go wall, this one, and we need to make sure we get all of these little ones in here. Okay, I think that's all of them in there. And then we do the top one, we do this one, and we do this one. And then we can hit OK. And that all generates, that's all good. And now, lastly, we hit simulation run. And hit start, and we make sure there are no errors. So, some areas that could occur are you haven't selected all of the walls in this one, and that'll come up saying it's an incomplete volume, or you haven't selected the gas, or there is no velocity in the velocity inlet. But hopefully all of that worked. So, come back a second. So, after we open the view results menu, what first thing we're going to do is we're going to click faces and go hide selection on the top one. And this one, hide selection, there we go, that worked. This one, hide selection. This one, hide selection. Click it. Click it, hide selection, this one, hide selection, this one, hide selection. Alright, so we just have this box. Now we're going to add a particle trace, and we're going to click this wall down here, and that's going to flow over the box. And now we're going to add animation. And we can change cylinders to spheres. And if we click play on the animation, you'll see, oh, no, what we want to do is we want to change this to particle trace. And then hit play. And you can see them traveling over the object. So what this allows us to see is where on the object is more efficient, where it is less efficient. Now we can change the speed to slow down a bit if you think it's going too quickly. So now I want you to have a play around with this and see what you can work out and what you can learn. And if there is anything you want to change in your design to make it more efficient, go ahead and do that. And then we'll have a talk about it in a sec. The look of the race car is important to your marks as its function. So I want you now to start designing different motifs to cover the car in. We can look at maybe a flame design, like a Hot Wheels car, or flowers, or whatever you would like. But it's important to justify this along with your simulations within your documentation to allow for me to understand what you're doing in your marks.